Hello everyone. In this video we will be discussing about the operators in Python. Actually it is very important to learn about the operators in Python. Why I am telling is, like in C language, in Java or any other programming language, the operators are mostly common. But while coming to the Python, there are different operators are there which will help or differentiate the style of coding what you write. We don't have, we have logical operators also, but here we are, the usage of logical operators is different. If we learn operators in C language, and we directly, if we start learning working on the programs in Java on operators, then it is easy. But while coming to Python, there are few things which are differentiating. Not tough, I don't say it is tough, but very easy, but we should know while if you have to work on any programs. That's why for me the operators video is coming as priority compared to any other topic. So let us start now. So guys, operators are totally here 7 operators are there: arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. Let us start with arithmetic operators. So these are the arithmetic operators we have. Plus, which is going to indicate the addition. 4 plus 7, which is nothing but 11. Minus, subtraction, right? 12 minus 5, 7. Multiplication, division. And from here I will be explaining you the programming example also. Why? Because addition, subtraction, multiplication is common. The division, modulo, slash, double slash, and double star, these are the examples we are going to look at now. Okay, so let us start now. So let us take a value as 12, b value as 3. Okay, so now what I am writing is print a slash b, or instead let me take 5. Okay, so if you use slash, means one of the operator, right? So what is the output we are going to get? Let us see. 2.4. Here observe, we are going to get the result with decimal points also. Floating 2.4 like that, we'll get exact answer. If you look at, double slash, if you are writing double slash, what is going to happen? We are going to get only quotient. And do remember here, 5 2s are 10. That's it. If you go with any example, if you take here, let me get back with notepad. 12 is given, and I'm writing 5. 5 2s are, what is the answer we are going to get here? The answer we are going to get is 10. Okay, now the remainder what we are going to get is 2. If we are using double slash, we are going to get this answer. That's what I am showing in the code. If you are using double slash, I am going to get the answer 2. If you are going to use single slash, we are going to get what? 2.4. Means how we are getting this? Again, this 2, you are putting point here, and that will become 0, just like normal mathematical division. 2.4, and the answer we are going to get is 20, and you know the result 0. Until you get 0, you are going to work on, like 2.4 or something like we are going to get. So that is the difference between usage of slash when compared to double slash. Hope you understood. So coming to modulus. Modulus is the operator which gives the remainder. Okay, whatever the remainder, 10 modulo 4 you are doing, what is the remainder you are going to get? 2. That remainder going to be returned if you are using modulo operator. This is new one. This is not there. These two operators are not there in any like C language and Java language. These two operators are new here when compared to C and Java. So double slash is what it is giving? It is going quotient. In C language, single slash is going to give the quotient. But here single slash is also going to give the quotient value, but with decimal points. That is the thing you need to remember. Double star. So it is what we call it as exponent. something like A double star B. What you are going to get? The output 12 power 5. Let me reduce the value. 12 squared. What is the output you got it? 144. A power B. 12 power 2. 12 power 2 how much? 144 is the answer we are going to get. So now after this, let me go to the next one. Arithmetic operators over assignment operators. All assignment operators we know mostly x plus equal to, which is 5 is getting stored in x. Okay, so plus equals to, this is one more assignment operator we have, which is nothing but if you are writing the example like this, x plus equals to 3, which is nothing but I can use, instead of this also I can use x equal x plus 3. X equal x plus 3 also the meaning is x plus equals to 3, and minus equals to, you can write like this. If you take this example, that this particular step can be used as x minus equals to 3. This is nothing but x equals to x minus 3, and you can guess what is this. X star equals to 3. What is the thing you are going to get? X equal to x into 3. You just look at here. X equal to x into 3. Slash. X slash equals to 3 is nothing but x equal to x by 3. These things you can work out, I think. Okay. It is not compulsory that you have to use like this. Assignment operators obviously you are going to use. Instead of all these operators, we can have alternates. We can use like this. Okay. So now let me shift to the next operator, comparison operator. Okay, these operators also very well known operators in mathematics. Double equals to, which compares LHS with RHS. LHS with what? RHS. Not equals to. Again, LHS is not equals to RHS you are checking. If x value, for example, x is not equals to y you are writing. X value 2, y value is 3. Obviously 2 not equals to 3. 2 not equals to 3. That's why this statement will be true. Greater than, less than, greater than or equals to, less than or equals to, obviously these are the same mathematical steps we are going to use. When you have to compare LHS with RHS, this is what we need to use. Mathematically little bit different here. Less than or equals to, greater than or equals to should be written here like this. Okay, these comparison operator and assignment operators are quite easy. That's why I am not showing the example. For this arithmetic operators I have explained. Okay, assignment operators, comparison operators. Now I am coming to logical operators. This is interesting. And or not. And or not means, if you are using end statement, if both the statements are true, then only answer true. Otherwise answer is false. If this condition is true and this condition is false, the answer is false. So here, in order to get the condition true, all the conditions must be true, and that's then only the condition, entire condition will become true. Otherwise false. At least one condition is there, then the entire condition becomes false. Or at least one condition is true, then entire condition and things what you are writing here all will get true. At least one should be true. Here at least if one is false, na, entire statement becomes false. Here at least one true is there, na, entire statement will become true. That is the difference between and. And means and every statement must be true to say true. Or means anything at least one is fine. Not whatever the answer you are getting, quite reverse answer to that. Let us see the programming example for this. For example, I am taking A, B and C equals to 5. Okay, I am writing if A greater than B and A greater than C. Print hello. Else print by. So now tell me, this condition is going to be true or false? A greater than B and A greater than C. A greater than B, 12 greater than 2, true. This is true. A greater than C, 12 greater than, both the conditions are true. That's why this if condition gets true. That's why we are going to get the output hello. If at least one condition is false here, now the entire condition becomes false and we directly control will go to else. I will show you. What is the output I am getting? Hello. Why? Because both the conditions are true. For example, if I am writing 15 here, 12 to 15, A greater than B, it is true. But A greater than C is false. Means one false statement is there. That's why the entire condition becomes false, and directly control will go to else, and where it is asking to print by. And see what is the output we are going to get. The output what we are going to get is by. And in this case, instead of and, you put or. Instead of and, you put or. You see now. Now you will get output hello. Why? Because at least one condition is true, na? That's why the entire condition becomes true. That is the difference between else and, sorry, and or. Now look at hello, we got it. Here, why we got hello here? Though the second condition is false, the system is taking first condition as true. At least first condition is true. At least one. That's why the entire condition become true. That's why as if block is, if condition is getting true, hello is getting printed. Instead of putting or, if you put n again, you will get what? By. Okay. So for example, not is there, right? Not should be written, whatever the condition you are writing here like this. If you are writing before that not, what does it mean? Whatever the condition it is happening, if the this entire condition is become true, na, not will make it as quite opposite to that. Not. Now let me execute. What is the output I am getting here? Why I am getting hello? Just check out. You look at A greater than B, A greater than C, A greater than B and A greater than C. This condition is false actually. Why? Because A greater than C is false. True and false. False, na? For that what you kept? Not. For the false condition, not you kept. Means it becomes true. That's why I am printing hello. For example, I am putting or. A greater than B is true. Right. A greater than B is true. A greater than C is false. True or false? Actually true, na? At least one condition is true, na? Before that, what you kept here? Not you kept. Means this entire true condition becomes false. That's why you will get by. Opposite. Whatever the answer you are getting, opposite to that. That is the purpose of not. And or not. These are the logical operators we have in Python. I'll show you now. So, and or not. Okay. So now, identity operators. Just checking LHS equal to RHS. If X is Y, if you are writing the condition X is Y, means if X equals to Y. If LHS is equals to RHS, then only this condition true becomes true. X is not Y. If both are not same, then this condition becomes true. Is not, identity operators. These operators are not there in other programming language like C and Java. Here in Python it is there. This is what you need to concentrate. Identity operators you need to concentrate. Logical operators you need to concentrate. Comparison operators are same, but assignment operators, before that, these slash, double slash, this quotient, these are things you need to concentrate here, which are not there in C and Java. Okay. Now I am coming back. Easy is not, right? I'll show you the programming output for example for this. Easy is not, right? So what I am writing is, here I am going to remove all. X is Y. What you are checking here? If X is Y, sorry, A is not. If A is B, A is B. Here we have example AB. That's why I am taking AB. So A is B. The condition what it is checking is A value 12 is equals to B value. 12 equals to 12 is there. Huh? Both are not different. Na? Both are not same. Na? 12 and 12 is 2. 12 is 2. False. Na? If B also 12, na, then this condition will become true. Check out. LHS equals to RHS, something like that. Look at hello. You are getting hello. Why? Because this if condition is getting true. Why this if condition is getting true? 12 is 12. Both are same. For example, let me change this. 12 is 2. This condition becomes false. That's why as the condition is failing, you are going to print the message by, else whatever things you are written in the else. X is not. I am writing is not. A is not. A is not B. Yes, obviously 12 is not 2, na? The condition is true, na? You will get hello now. Check out. You're getting. A is not B. That's what you're checking. A is not B. 12 is not 2. Earlier what you did? What you have checked? 12 is 2. Is it true? No, false. That's why you're getting by. You will get by. Check out for this. Okay. By. So these are very interesting operators. Easy is not identity operators. Okay. So far you look at, we have discussed about arithmetic operators, assignment operators, comparison operators, and logical operators. Logical and or not. We don't have double and or not. We have a and d, or not. And identity operators, easy is not, means checking both values are same, both variable values are same. If both values are same, it returns true. Otherwise it returns false. Otherwise it returns false. Is not, what it will check? Check both are not same. If both are not same, na, it returns true. Otherwise it returns false. Now let us discuss about membership operators. So membership operators are two. The first one is in, not in. Okay. For example, I will discuss this with the help of example program. Assume that I have a variable a where I can store the element set of elements like 1 comma 2 comma 3 comma 4 comma 5. So you may get a doubt how he or she is storing by using a square bracket. This topic I will discuss later, but as of now do remember that I am storing some set of elements into a. Okay, these are the elements 1 2 3 4 5. 5 elements I have stored. Okay, so I am checking if some, let us suppose 25 is the number I am taking. 25 in a, what does it mean? Means you are checking whether this 25 number is available in this set 1 2 3 4 5 is there or not. In is in operator talks about that. For example, print. Okay, let me write print. Here I am printing hello, else print by. So if 25 number is available in this set 1 2 3 comma 1 2 3 4 5, then this condition will be true. Otherwise the condition gets false and else block will be displayed. Okay, now see here what is the output I am getting. What is the output we are getting here? By means condition is false. Why the condition is false? 20, you are checking whether 25 is in A. Is 25 available in this set? No, na. That's why the condition is false. For example, I am checking 5. If you 5 in A, check number 5 is available in this set or not. 1 2 3 4 5. 5 is available here, na. That's why this condition becomes now true. That's why we'll get a message hello. Have a look. Just look at what is the output we got it here. Hello. Hello is the output we got it. So for example, we have one more, not in. Not in. So 5 not in A you are checking. So you are checking 5 is not available in A. Is this condition? 5 is available, na? Not available, na? So 5 not in A. So this obviously this condition becomes what? False. Check what is the output we got it. As the condition is failed, we are getting a message called by. Why we are getting? If the condition is false, else block is getting executed. For example, if 25 not in A, correct only, na? 25 is not in A. That's why this condition becomes true. Then hello message will be printed. So just look at hello message will be printed. This is how the in and not in operators works. These are the membership operators. Now I am coming to bitwise operators. Very important and interesting topic. Bits. What is meant by bits? First of all, you know that computer can understand binary language. What is binary language? Which is in the form of zeros and ones, right? Zeros and ones. So we are dealing with those zeros and ones in this particular video. Okay, very first let us see what are the bitwise operators we have. Thereafter we'll go one by one. Very first, bitwise AND is there. The representation of bitwise AND operator is like this. Next one is bitwise OR. Bitwise OR can be represented with the symbol like this. This one. XOR, you can write XOR simply. EXOR is not compulsory. XOR also sometimes can be represented. XOR operator is symbol is this. Okay. So right shift operator, left shift operator, and bitwise not operator. So these are the bitwise operators we have. We need to work on each and every bitwise operator, and we need to know why a particular result we are getting by applying bitwise and how we are getting that result also very important. So in order to understand deep level of coding, these models are these kind of operators are very essential, and we should know everything, how we are getting the result, how we are getting the output. So let us get back into one by one each and every operator. But before knowing or working on the bitwise operators, we should know how the binary number representation can be done. For example, 12 is given. For example, 12, number 12 is given. How that 12 number can be written in binary form? In form of binary means zeros and ones. Na? How we can write them? I am showing one example here. Binary number representation. Okay, very first I will explain that. My topic is bitwise operators only. But before going to each and every operator, I will be explaining here binary number representation. Okay. For example, the 70 number is given to you. Okay, the number 70 is given to you. So 70, how I am writing is, look at, these are the representation of how we have to write these numbers. 2 power 0, which is 1. You just ignore what I have written here as of now. 2 power 0, 1. 2 power 1, 2. 2 power 2 is 4. 2 power 3, 8. 2 power 4, 2 power 5. 2 power 6, 64. 2 power 7, 128. If I need more and more numbers, you can write 2 power 8, 2 power 9 also. And see here, I need to get 70. Out of these all numbers, you just pick some numbers so that I will make addition 70. 64 plus 4 plus 2. 64 plus 4 how much? 68 plus 2 how much? 70. Number 70. Just across those numbers where you have considered for getting 70, above 64 you put 1, above 4 you put 1. Why? Because 64 plus 4, 68, plus 2, 17, plus 1. So 1 you consider. Remaining all the places you put 0. Why? Because you are not considering them. Whatever the numbers you are considering for getting the result, decimal number or number, those number places only we have to put 1. Remaining places we have to put 0. The arrangement should be like this. Rightmost to leftmost. 2 power 0 starting. 2 power 1, 2 power 2, 2 power 3, 2 power 4. It is not compulsory that always you should write this much big. You can write 8421, 4 bits code also. Okay. So how I had written 101000110 is the binary number representation for what? 70. For example, let us consider these 4 bits only. Let us consider these 4 bits. 0110, right? So what is the this normal number, natural number? What is the natural number for this? 0110. What I will be answering is 8. At the place of 8 you kept 0, so I am not counting. At the place of 4 you kept 1, so 4, plus at the place of 2 also you put 1. 4 plus 2, 6. At the place of 0, sorry, you kept at the place of 1 you kept 0. So 1 is not counted, 8 is not counted, 4 plus 2 is counted. So up to here the answer, if you are asking me 4 bits, what is the answer? I can say 6. Hope you are understanding what I am trying to tell. Okay, so let us now, from with this basic idea what you have, what you are getting for binary number system representation. This is very important. First of all, to need to work on bitwise operator. So be careful in writing the binary number for the given numbers. Okay. So for example, I am writing like this: 0, 0, 0, 1. Okay, I am writing like this. So up to here you observe, I have written 1 only under 8. Remaining all places after that, I have written zeros. Means I will be counting 8. So for this, what is the number? What is the natural number we are getting this? 8. What is the natural number we are getting for this? 8. For example, I am writing one more number. Just observe here: 1, 0, 1, 1. And for this, what is the output we are going to get? Count 8, count 2, count 1. 8 plus 2 plus 1. What is the number we are getting? 11. Like this, binary numbers can be converted as decimal numbers, we call it natural numbers, and these numbers also can be converted as binary numbers like this. Okay, do remember, this is very very important. Now let me shift to uh, bitwise operators. Okay, so bitwise AND operator, very first, this is the symbol we are using. Okay, so very first let us see the truth table. This is the truth table. We say if we have two zeros in bitwise AND operation, if we have two zeros, then the result is 0. Okay, if your AND na both should be 1, like this, both should be 1 to get the answer 1. Remaining all the cases, the answer will be 0. A value should be 0, B value is 0, then answer is 0. If A value is 1 and B value is A value is 0 and B value is 1, then also 0. So AND you are using now, both should be 1, both should be true. 1 in the sense true. False, 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 true, false. Why false is AND, both should be true. False, true, false. 1 0 0, both are 1, true true, that's why answer is 1. So you observe here, bitwise AND operation I am doing. I have written the binary number representation for 2 and binary number representation for 6. Now I am doing AND operation. From here you have to do 0 and 0, what is the value? 0. 1 and 1, what is the answer? 1 1. 1 and 1, what is the answer? 1. That's why I have written 1 and 1 1. 0 and 1, 0. 0 and 1, what is the answer? 0. 0 and 0, answer, what is that? 0. And can you guess what is the output for this? This is the output, we got it. And what is the answer? The answer is 2. Bitwise AND between 2 and 6 is, the answer is 2. You observe, you see this in real time example. I am writing int a equals to 2 comma b equals to 6. These are the values given, right? Here I am writing, let me take out one more variable, c equals to a and b. Printf, I am printing only c value, percentage d comma c, and see what is the output I am getting. The output I am getting here is 2, but many of us doesn't know how we are getting this answer 2. The story behind, the logic behind this is this slide. Bitwise AND between 2 and 6 is, this is the answer we are getting, and this is the natural number for this is 2. That's how we got the answer. You just see bitwise OR. So the symbol used for bitwise OR is the straight line. You can see this straight line above the enter button in your keyboard. Okay, so OR is quite interesting. If at least 1 is there, at least 0 or 1, answer will be 1. Well, coming to AND, we just look at AND. Both should be 1 to become 1. In all remaining cases, your answer is 0. But in case of bitwise OR, if at least 1 is there, then answer is 1. In order to get the result false 0, both the values should be 0. 0 and 0 or 0 is only 0. Remaining all cases 1. Now let me see the example for bitwise OR. A value is 10, B value is 7. So binary representation is this. You can see in the starting of this video how the binary representation I have explained. The similar way it is converted to binary number. And 1010 is 10 and 10111 you can write left side 0. So you are performing bitwise OR operation between these two. 0 or 1, what is the answer? 1. 1 or 1, the answer is 1. 0 or 1, answer is 1. 1 or 0, answer is 1. You see, 0 or 1, answer is 1. 1 or 0, answer is 1. Like that we are getting answer. 1 1 1 1, which is the final answer. We are natural number we are getting here is 15. We call it as a decimal number here. In mathematics, decimal number is 2.5 like that, but here decimal number is not that. Natural number we call it as decimal number. Bitwise OR or bitwise XOR. This is quite interesting. XOR easily you can remember. If 2 bits are same, A and B are same, then only answer 0. If 2 bits are different, the answer is 1. 2 bits are different, answer is 1. 2 bits are same, answer is 0. If 2 bits are same, answer is 0, otherwise 1. So again, A value 10, B value 7 given. Same example taken, 0 1. 2 bits are different, that's why this answer is 1. 2 bits are same, answer is 0. 2 bits are different, answer is 1. 2 bits are different, answer is 1. 1101. 1101 is the binary representation for the number 13. And the same thing I am applying. Okay. So now let me shift to the next one. Hope you understood what XOR is. So far I have discussed about bitwise AND, bitwise OR, bitwise XOR. Next one, left shift operator. This is the symbol less than double time we have to write left shift operator. For example, your value is 101. If you are asking to perform left shift for one time, this one will come to the next place like this. This one shifted to left, and at the place of 4, 1 is there. Na? This one will be shifting to at the place of 8, and 2 at the place of 2, what is that? 0. It will be shifting to left 4. When you are performing left shift operator, you just start from here, left to most side, not right most side, left to most side. From there you need to shift here to here. This will be shifting to 4. At the place of 1, 1 is there, that will be shifting to at the place of 2, and remaining this place you can put 0. So 101 is the value given. If you are asking to perform left shift, it has become like this. The original value is given is 5. After performing left shift operation for one time, it has become 10. Okay. Again, if you are asking me to perform left shift operation for this, again you see here, this one will go to the place again. So again, don't take this example. So this will become next to 20. Okay. So this will come here, this will come here, this will come here, this will come here, and it will be 20. Directly one more time here we have done for 10. For every, simple to remember, for every left shift operation the value gets doubled. Okay. So now let me shift to the next one, right shift operation. Again it is quite opposite. So from here you need to shift to right side. This is 0, it will go outside. From here this value will come to here, this value will come to here, this value will come to right side. Means moving the bit one place right. You may ask me, what if the first bit is 1? It is going out of boundary, so you can neglect it. Okay. So 14, after performing right shift operation, it will be like this one will come here, this one will come here, this one will come here, and 1 1 1. 4 plus 2 plus 1. What is the answer we are getting? 7. You can observe here, for every right shift operation the value is getting half. For every left shift operation value getting double. For every right shift operation the value is getting half. Again, and after that at last we have bitwise NOT. This is a congruent symbol, and for this don't think much. If the input value is given 5, the output you will get it as -6. If you give the value 10, it will become -11. So far we have discussed about each and every operator: bitwise AND, bitwise OR, bitwise XOR, bitwise right shift, left shift, bitwise NOT.